6.1, 6.2c. Okay, let's see how you did. We have $10,000 at 3% compounded quarterly for 5 years. And we end up with $11,611.89. Okay, great. Let's go on. We're going to look at an example of basketball players. Basketball players have a statistic, and they say total points. Basically, total points is a statistic. Given by P of T U V, and that happens to equal T plus T 2U plus 3V. Now T stands for the number of free throws. All right, and U is number of 2-point field goals. And V, you guessed it, number of 3-point field goals. Okay, so let's find P of 5, 8, 3. That means 5 free throws, 8 2-point field goals, and 3 3-point field goals. Okay, so we put it into the formula. And we have 5 plus 2 times 8 plus 3 times 3, 5 plus 16 plus 9, which equals 30. Okay. I'm going to talk about 2-dimension and 3-dimension. We've been dealing with 2-dimensional graphs, and now we're going to deal with 3-dimensional graphs. So let's give an example. Here's a 2-dimensional graph. We have y equals f of x. In this example, y is going to equal x squared. So to graph y equals x squared, we have x, f of x. We put in a 1, we get 1. We put in a -1, we get 1. We put 0, 0. We put 2, we get 4. We put a -2, and we also get 4. And so we graph our graph. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. Here's our x, here's our y. And we graph our points. 1, 1, -1, 1, 0, 0. 2, 4, -2, 4. We've done this before. Okay. All right. Notice this is 2-dimensional. We have an x-axis and a y-axis. Okay. Imagine if we had another axis. So we'd have an x and a y, and then we'd have 1 that would make it 3-dimensional. So imagine my pen being a z-axis, so it makes it build, and we can make 3-dimensional shapes. So let's give an example of taking a 2-dimensional shape and then making it 3-dimensional. Okay, so let's start with the equation x squared plus y squared equals 1. All right, x squared plus y squared equals 1. I'm going to put x, y. If x is 0, if I put a 0 there, then what's y going to be? Well, it'd be y squared equals 1, which is plus or minus 1. If I put a 0 into the y, put a 0 right here, then x is going to be plus or minus 1 as well. So let's graph that, those points. 1, 1, 1, 1. All right. So we have 0, and then we go 1, 0, -1, 1, 0, 1, -1. And basically what it is a circle. Okay, so that is a two-dimensional graph, okay, where we can write it on a flat piece of paper. let's change this to three-dimensional. So let's try to do this. I'm going to make, this is our x-axis, this is our y-axis, and then here's our z-axis. If you can imagine, that's three-dimensional. So what would we do is we could put this circle right here. I'm going to try to put the circle. All right. And then we would raise it. Like, let's say we have a cylinder. So now we have a cylinder. We laid the circle flat on the XY plane, and then we raised it, and now we have three-dimensional shape. Maybe you can see it better that way, three-dimensional. Okay, so in this case, we're looking at z equals f of x, y. Remember over here, we had y equals f of x. But here, we have z equals f x, y. And the points for this are actually going to be a point x, y, and z. So let's say this point right here, we'd have to go over x and then move our y, whether we're going up or down our y. So let's say we go here to x, we go over to y, and then we go up to z, and that would be our point. Okay. So now I'm going to give you three-dimensional graph that I'd like you to put the points on. Okay, so I'm going to erase this right here. Okay, all right, so we're just going to graph a point. We're graphing an XYZ point. And I'd like you to try to graph right now on your graph 1, 2, 3. And to help you get started, we'll just make some points there. Some lines there, some lines there, okay? So try to graph 1, 2, 3. And then I'm going to give you some more points so you can get some practice at graphing three-dimensional. In 3 dimensions, I should say, huh? Okay. Well, let's see how you did on 1, 2, 3. We go 1 in the x direction, put an x here, 1 in the x direction, 2 in the y direction, and 3 in the z. Remember z, this is 0. So we're going to go 1, 2, 3. So this point right here is 1, 2, 3. I'll do that again. We went over 1 for x, we went over 2 for y, and we went over 3 for z. Well, even though we're here, really z starts here. And so then we go 1, 2, 3. And it puts it right there. Okay? Now let's do 2, 0, 0. We move 2 and we don't go anywhere. How about 2, 2, 0? We go 2 and we move 2 and we don't go anywhere. All right, very good. Now, we're going to go on to 6.2 now, which deals with three-dimensional shapes.